Later, guy.
What up, Elbo?
Not much, man. What's going on?
Chilling.
So, Jeremy, do you think a flat Earth would require a figure-8 sun?
Talking about the analemma?
Don't worry about the analemma for now. We'll get there. Just in general, for opposing rotations on a planar disk, one of the bodies of evidence would be a figure-8 sun, right?
Yeah, they call that the analemma.
I appreciate it, but we've only seen the analemma. Well, I shouldn't say we. For the most part, you've seen the sun analemma through time-lapsed photography or the figure-8 put on the sphere. But has anybody ever seen the observation from the equator looking up, facing east, looking up at zenith and noticing the opposing rotation, creating the illusion or reality, who knows, right? If you're looking for a figure-8 to create opposing rotations, you could actually observe a figure-8 being created over a year from the underneath.
At the equator. At the equator, you'd have to do it in a time lapse. So when you said we've only ever seen it in a time lapse, but at the equator, there's something different happening. I mean, you still need a time lapse.
But you're not. No. So the observation that I'm making is not an observation at the equator. The sun analemma is not done in the equator, right? The observation I'm talking about, I'll do a video of it. I'll post it for you. You can take a look. It would be really interesting to see this time-lapse video because you would actually see an infinity symbol being created across the sky. Not like the sun analemma that we see in that time-lapse. It's actually you're viewing it at zenith. That's not a zenith image we're seeing when we watch the sun analemma.
If you're just checking the sun at zenith, there's no figure-8. You just have the sun in the sky at zenith at your 90 degrees.
So right, listen, when you face east and you look at your zenith, you're going to see the sun during the northern summer.
If you're facing east, you're not looking at your zenith.
You're facing east, but then you're looking up at your zenith from east. Yes. So what you see is your zenith. You're looking up. You still see the sun rise east and then settle northwest. Okay. You see that in your view.
But it doesn't matter if you face north, west, south, or east. If you're looking at your zenith, you're just looking up. What does it matter what direction you're facing?
Because you're facing east, sun rises in the east and settles in the west. So if you're facing east and you can see a figure-8 being created in the sky, this would give you the illusion of two opposing rotations. And you can actually see the figure-8 being created in the sky. In other words, what you see during the solstice to the equinoxes to the solstice or vice versa, you will actually see at the zenith point facing east, you'll see the circle rotation in the north for a while. Then it will cross over the equator, making a beginning of a figure-8. It will do it again and then cross back, making you an infinity symbol in the sky. I don't know why nobody's ever seen this. You can see it in Stellarium.
You still going on about this? Hey, Crizzle, are you there?
Nobody's made the fucking observation, guy. You can see this in Stellarium. I already documented it and posted it online, but nobody's ever shown it. I can show you an infinity symbol looking at the equator in Africa, Campanella, looking east, facing up, looking east. So you're looking east, but your zenith, you still don't have a 360 or 180 degree view, right? So, but you can see it rise in the east, settle in the northwest, rise in the east and settle in the southwest. But while it does that over the year, it has to cross the equator, giving you an infinity symbol or figure-8.
Do you know you could turn a normal dishwasher into an air conditioner?
No one cares about the figure-8. That's funny.
What's the point?
It means it's all fake and gay, but
what's the point of the figure-8, dude?
He's into the analemma, bro. Gives him a boner.
You don't understand. So for opposing rotations, right? If you have a figure-8 created above you in the sky, it would allude to opposing rotations, giving you those opposing rotations. Now, because we time lapse the star movement with a optical device that converges straight lines into a vanishing point, Who knows what fucking illusions, other illusions it's creating, right? Point is that if I can show you a figure eight at the equator, and it goes northwest, it rises in the east, settles in northwest, and then rises in the east, settles in the southwest, and it makes a figure eight doing it. That's kind of cool. How does that work on a globe?
I don't know.
You'd have to turn somebody upside down, right? Somebody has to be antipodal. That's the only way I see it working. You ever seen the Chinese flat Earth map, Jeremy?
Elbow, I figured out how to do it, bro.
How is it?
Elbow, you there? We get a fish tank. All right.
All right.
And then we fill it with water. And then we put something and we shoot it across. Like you put something in the water. So now you got the ground spinning and the medium spinning. You shoot something across and through the water. And then you record that while the camera's spinning with the fish tank. And then you do it again and you record it with the camera not spinning with the
Right.
fish tank. And then you overlay the lines that the object traces out. Jeremy?
Isn't that Fresnel drag or something like that?
That's the Coriolis effect.
Coriolis on loop. Like optical Coriolis?
Tank, bro. And the rotate. Coriolis is all
How many
optical.
kind of Coriolis are there?
It's always optical. Elbo, you heard what I said though, with this how we could see if it's happening or not, and then you
Yeah,
overlay
yeah.
the lines that the object traces out and see if they're the same.
Yeah,
And then if we
I
saw the
like that
Coriolis,
idea.
if those lines don't match, right, then there's a Coriolis effect, right?
Yep. If it doesn't deviate, if it doesn't look like it's deviating from the inside, and it's
Yeah. So the
doing
lines
the same thing on
would
the
have to be the
outside.
same lines. Yeah. So if you can't overlay the lines, then there's the Coriolis effect.
We have to do it. We have to record the same one at the same time, though.
Bro, how though? I was thinking about how
Two
you would do
cameras.
the same one
Two
at the
cameras.
same time. Yeah, but
Two
you got to
cameras.
have it at the center. You got to have them both in the center, though. You got to have them in the same spot, basically. Why can't you just shoot the thing out one time and then record it and then shoot it out the same thing another time? Same shit.
Because you might not do it exactly the same way.
Jeremy
All right,
doesn't
well,
like details like that.
how do you record them? How do you record them at the same time?
You can use a mirror to do
Two cameras.
crosswise, like intersect in the middle.
One's got to be
Yeah, all you
rotating
need
and
is two
one's not
cameras.
rotating, though.
Yeah. One
They
has
need
an
to be in the
outside view.
same spot.
The other one has
They got to
the
be at
inside view.
No, you do them from the top down, but one you just have rotating with it. That's how you would overlay the lines. If you have the cameras in the same exact spot.
So in the
Because when
chat,
you do that with like if you do this in a merry-go-round, you have the
Have you ever
outside
seen the
perspective with
MIT?
camera with the outside perspective.
You ever see when
You have the
MIT did
outside
it?
perspective and you have somebody inside.
No, it's not about outside or inside. It's about one camera's rotating and one camera's not rotating. So one's in the inertial frame, the other's in the non-inertial frame.
Yeah, once on the outside from the outside perspective, watching the thing go straight, while the guy in the inside, when he's spinning, it looks for him
It's
looks
not
to
going to
him
go
like it's
straight
deviating.
though. It's not going to go straight though.
Well, that's what it has to happen.
You can shoot it straight. It's not going to go straight though because the medium's rotating with it.
Exactly my point. There's no Coriolis.
Yeah, but you shot it straight though. It's just them things rotating.
So when you're on a merry-go-round and you try to throw it to someone in front of you, right? The ball seems like it misses him and deviates one way. Now, from the outside, the person looks at it and it looks like the ball's just going straight. For the inside person, it looks like it's deviating to a different location, not where you threw it at. And that's the problem with the you're with let's say the rotating floor and the atmosphere rotating with it. If that person throws it, that ball's gonna do the same thing. It's gonna rotate with the water. And from the top view, it's just gonna look like it's going around in a circle instead of actually just going straight. You see what I'm saying?
Yeah, but it's not going to go straight, bro. You're not going to see it go straight because it's in a medium that's rotating. However, it's not
Therefore,
going to
not
overlay.
Coriolis.
Well, no, you're going to shoot it straight. It's just not going to go straight. However, it's not going to overlay with the other one though, because there's Coriolis there.
No, no, no. The thing is, from the outside perspective, that ball or whatever we threw has to go straight.
No,
That's what we're saying.
it doesn't have to
This
go
in
straight.
Coriolis when they say, yes, from the outside perspective, if you are on a merry-go-round and you see somebody throw a ball, for you, the ball is going straight. Now, for the person in the inside that's having a rotating reference frame, it's not. That ball is
All right,
just deviating.
you're tell- so you're telling me if I throw a curveball off a merry-go-round and it doesn't go
Curveball.
straight because it's a
We're not.
curveball, you're
Yeah, we're
telling me
not throwing.
there's no
We're not doing
Coriolis?
curveballs. We're not doing curveballs. When a person in the Coriolis
I'm
is
asking you though. I'm asking you though. If we were to throw, hold on, bro. I'm asking you if we were to throw a curveball, right? Instead of a ball in a straight line, if we were to do a curveball, then there would be no Coriolis.
well, I mean, that's a different.
Elbow.
That's a different idea. It's not the same as what the Coriolis is showing.
Coriolis.
I'm not.
Bro, it doesn't have to go straight. You can still take a curve past the initial frame. It just deviates from its path and not inertial, bro. Like
You kind of
if you
broke
were
up.
on a merry-go-round and threw a curveball off, it's not. What's up?
Yeah, you
What's
kind
up?
of, you kind of broke out of it. Say it again.
Posted a really good video in the chat
I'm
real
just saying,
quick
bro. Like,
of them throwing a ball in a rotating room and filming it from both ways, filming it from both perspectives. and you can see the room is rotating. They're in the room. Basically, they're on a merry-go-round in the room. At 3 minutes and 5 seconds is when it starts. They start throwing the ball, and it shows it from both perspectives.
I know, but the thing is, Cole, he wants to see it go straight in the one frame, but he wants the medium to be rotating with it. So I was going to do it in a fish tank. But he says if it's not going straight, then it's not Coriolis, which brought me to the curveball and the merry-go-round thing, which there's still Coriolis there because it's deviating off its path, off its actual path.
The way they
But
show
you
it
get
in
that,
the
right,
video
Elbo?
is the way they showed it in the video is when the camera's not connected to the rotating room, and they throw the ball.
What up, Elbo?
Have you thought about working for the bank?
Elbow, are you telling me that if I throw a curveball off a spinning merry-go-round and it's not a straight, and the person on the merry-go-round sees it deviate from its actual curve path, you're telling me that's not the Coriolis effect? Elbow.
Yeah, we got to try that because I don't think is they.
And what do you mean by curveball?
Because what?
He's making the bullet curve like wanted.
No, just a baseball. Just a baseball. There's a pitcher. He knows how to throw a curveball. He throws a curveball. You know what I'm saying? In the inertial frame, you see one path. In the non-inertial frame, you see a different path.
Yeah, if it curves towards your location, it's not a Coriolis. Like if he actually throws it perfectly where it actually curves with.
So you're telling me the paths would be the exact same. What if I curve it the other way? Why can't I curve it the other way? I just want to make sure we're on the same page where you can't have the Coriolis effect, even if it doesn't go in like a perfectly straight line. I mean, bro, nothing goes in a perfectly straight line.
To me, it's one straight line. Now, dude, I'm telling you, if you look at a video, I don't know. Let me check what Copa.
I'm just saying, bro. If that guy was to throw a curveball, you'd still have two different things happening. It doesn't matter which way the curve goes or anything. Like, there's no way you can have Coriolis and both of the frames are the same. It's impossible. As long as nothing goofy's happening. Like, bro, can't we just do it in a sim to show what happens, or we have to have it actually done in the real world?
I'm gonna when I get home, I'm gonna download Blender and see if I could get Cloud
Bro,
to.
you're the computer guy. You're the computer guy. We're like 17 years into this, and you're just now getting Blender.
I have Blender, but remember I had to remake my PC.
Bro, you could probably just ask AI to just do it.
Yeah, I have Cloud. I paid for Cloud, so it should be able to do the whole thing for me.
Yeah, just have it overlay the frames and see they're not the same. Like, that's how you get those not the same ones, is because it looks like different things are happening. It's Coriolis effect. It's viewed from an inertial and viewed from a non-inertial. There's a real path in the inertial, and then there's this other path from the non-inertial because you're rotating. Have them do it with a fish tank, bro. Have them do it with a fish tank.
Uh, Again, like I said, I mean, because you in Blender, you're able to have multiple views, so you should be able to have multiple cameras set up. So yeah, it wouldn't be a problem. Um, but yeah, dude, I'm telling you, if you have the liquid moving with the body, I mean the Atmo or whatever
Yeah,
with
do
it,
it. Well,
is
when
gonna.
you do it in Blender, have it, or when you have AI do it, have them do it in the fish tank so
Yeah,
that it's all moving together.
I mean, it don't have to be in a fish tank. It just has to be. You could make it where the medium is way thicker and moving with, and then have the perspective from the top and perspective from the bottom and from inside.
Argument here anyway, guys. What are y'all trying to figure out?
There's people trying to say that if you have the medium rotating with the ground, that you're not going to have Coriolis effect, which I am heavily debating on because I wildly disagree with that statement.
What do you think, Cole?
I would think the thicker the medium, the more Coriolis you would have.
What? How is the thing going to deviate?
Maybe not.
Yeah, well, how is the thing going to deviate if it's moving at the same rate?
Because when it leaves, it's moving faster. Just like that little video I showed.
Because Elbo, one of your
So
cameras is
basically-
rotating. Hold on, real
Yeah, but I mean,
quick, because one of your cameras is rotating and one of them's not rotating. That's why it's going to look different. It's not going to look
I
the
was just
same. It's
saying-
definitely going to look different.
I was just trying to figure out if the medium would have any difference on it. I don't know. That's a good
The
question.
medium is gonna push it along.
The less medium. So, like, if you were in a vacuum, you can basically use the merry-go-round example. You throw a ball straight, it just goes straight. However, if it's like if it was a vacuum, there's no medium rotating with anything, so it's just going to go straight. However, once you start introducing actual mediums, water, air, jello, whatever it is, it's gonna change it's not going to be straight anymore, but it's still going to be the Coriolis effect because it's not going to be the same.
Are you saying that it don't go straight when it's in a medium, like? Because even in a vacuum, Coriolis is dependent
If you
on
shoot
the speed that it's rotating. Because that when you throw the ball, the speed that it's moving sideways around in a circle on the outside of the circle, on the outside of the merry-go-round, if you're on the edge, you're going faster than if you're in the middle. You know, just rotating. The edge always rotates faster than the middle, because it's further out there. It's got further to travel around in a circle, so it has to go faster to maintain the same speed. So when you throw a ball from the edge towards the center, it maintains that velocity that it has at the edge, but as it travels across the center and the center is moving at a different rate than the edge was, it causes it to look like it veers off to one side. That's what that video was showing a while ago. I just watched it. But I don't know at all about whether a medium has anything to do with it or not. That's a really good question.
No, of course, dude. If you have a vacuum with no medium above a merry-go-round and you throw the ball, it's going to go in a straight line. However, if you're spinning in a merry-go-round and you're in water and there's water spinning with a merry-go-round from the inertial frame, it's not going to go straight. It's still the Coriolis effect because it's deviating from its path, from its actual path.
I don't know, Jeremy. I'll let y'all. I just wondered. I'll let y'all get back to it.
I'm telling you right now, bro, if you're in a vacuum, right, and there is no medium, and you throw a ball, it's just going to go straight, right?
I'm following you.
Yeah, but then if you have a medium spinning with it, the medium's going to make the thing turn. It can't go straight anymore because now the medium's going to make it turn. It's going with the medium. There'll still be Coriolis there, but it's just going to look different than the straight line path. Now, Elbo's trying to tell me that if it's not straight, it's not Coriolis. I don't believe that at all. That's not true, bro. That's not true.
Yeah, from the outside perspective, it has to go straight because the thing is going. You're throwing it straight. From the inside, it's gonna look like it's gonna deviate.
Okay, so if there's two different paths, right? You're in the inertial and the non-inertial frame. And then in the inertial frame, it looks like it curves a little bit. But then in the non-inertial frame, it looks like it curves a lot of bit. What do you call that now if it's not Coriolis? What's that effect called? Think about it, Elbo. What's the name of that effect? You have no idea what to call that effect, bro, because it's called the Coriolis effect. When something deviates from its actual path because you're viewing it from a non-inertial frame, people throw a straight line in there just to make the example simpler. It doesn't have to be a straight line. You have no idea what to call that effect, bro, because when something deviates from its actual path because you're viewing it from a non-inertial frame, people throw a straight line in there just to make the example simpler. It doesn't have to be a straight line, dude.
Coriolis effect.